So, card games. Card games are a form of turn-based strategy game, and I'm actually really interested in how card games are actually implemented. Games like Hearthstone, Legends of Runeterra, they have a lot of systems to them, and like each card has their own effects, their own animations, and so on. So I really want to see how that's implemented, and what better way to do it or to learn how to do it than to do it myself, right? And the end goal of this is to essentially, once I've created a card system, I'm going to merge it with my previous project, and hopefully we can have a card game, RTS hybrid type game, where you play a unit, it shows up on the board, and then you can move it and do whatever you want with it. So I guess we have to start somewhere. So in this video, I'm going to be covering how to create card objects, I guess essentially where to store them, how to add them to your hand, and I guess mail them to the graveyard if your hand is full, and things like that. So if you can look at our project right now, we have 20 cards in our deck. We have no cards in our hand, and we have no cards in the graveyard. So if we were to draw a card right now, I'm going to hit the button. And once we draw up to 8 cards, we can see that that is our max hand size. So we're going to mill the rest of the cards to the graveyard. So if I were to draw a card right now, the deck count would go down and the graveyard count would go up. And that happens until I'm out of cards. And then you can see a debug in the console, hopefully. It's really small, but it says there's literally no more cards in the deck and we can't draw. And then we'd implement fatigue damage or something at this point. So to begin, I guess we're going to take a look at how to create card objects and how to get that all set up. So how are we going to implement cards? And essentially, I'll be implementing them with scriptable objects. And essentially what scriptable objects are, if you go to the Unity documentation, their description is essentially a scriptable object is a data container that you can use to save large amounts of data independent of class instances. One of the main uses for scriptable objects is to reduce your project's memory usage by avoiding copies of values. And this is pretty useful as cards essentially all have very similar information, that being like the name of the card, the mana cost, and so on. And we don't want a different prefab for every single card. So essentially what we'll be doing is we'll be making one of these scriptable objects for every single different card that we need. And then we'll just change the information depending on what card it is. Before we begin, let's actually take a quick look at the editor. And you can see that I've actually created 2 things already. The first one being a spell card and the second thing being a unit card. You can see that there are minor differences between the two. That namely being the unit card has a bit more information, which is the attack range, the movement range, and the hit points. These are the stats that our units use from our previous game, which is the turn-based strategy game. And essentially, that is the only difference between the spell card and the unit card. If we look in the inspector, if I drag this out a bit more, we can see that the unit card has a card display script attached to it. And one of the most important things is the card info. And this is essentially where our card object is being set. And the rest of it, the card name, card description, image, and mana cost, are all just connections to the various UI elements. You can see them being highlighted on the left. And essentially what happens is that if we were to play this game, the script on the start or the awake function would read the information from our card object, and then it would populate the information onto the UI itself. So if we were to hit play right now, you could see that the information is definitely generated and placed onto the card. So that is essentially how our scene is set up and how our cards are going to be set up. They're simply just UI elements with a simple script that reads a card object and then populates the card with the correct information. So we're in Visual Studio now, and we can look at the actual card object script itself and how it's constructed. So the only thing that's really important for making a scriptable object is this right here. Instead of having mono behavior in our class, just public class card object, which is what we're creating, and it is a scriptable object. And the scriptable object has this information on it, which is the card name itself. I have a card type enum, which is what I've created here. And essentially this allows me to differentiate between a unit and a spell card, because a spell card doesn't have the attack values, the movement range, and the health that units have. So that's the only, I guess, distinguishment between the two. And everything else has a card type, description, artwork, mana cost, and a card name. So we'll be leaving those for everything else. This other thing, which is create asset menu, file name equals new card, menu name equals card, allows us to essentially right click and create new. and then it'll give us the option for card, and when we generate it, it'll be called a new card. And what do I mean by this? We'll actually jump back into Unity, and we'll take a look at how we can do that. So let's say I have a folder here called test cards. What I would do, because I have created the scriptable object, and I've created the necessary information, if I right click, it'll go to create, and you can see that there's the card up here. Once I create card, it's gonna give us new card, because that's what we called it, and then that gives us our new object. So we can actually make a new card here. So card name is, I don't know, test card for video. It's a unit, and description is test card again. And we'll just put in the rest of the information, it's just a bunch of 5s. And you know what? For the artwork, let's just find some sprite that we have lying around. We can just click this, I'm pretty sure. You know, let's just have the castle wall as a picture, sure. So there, we have created our new card, and all we have to do now is go back to our cards, which we've placed it in new card. We're just gonna call this, rename it to test card for video. Excellent. And because this is a unit card, we're going to be placing it in the unit card information, or not the information. We'll be placing it in the UI. We will be placing it in the unit card because it has a different template. So test card for video, we're just gonna put that into the field right here. And if we hit play, we'll have a mountain wall, or not mountain wall, castle wall, I believe. And well, the rest of the information is here and it's loading correctly. So that's how that works, or that's how the scriptable objects work. If we were to return to Visual Studio for just one moment, we can take a look at the other script that we're using, which is the card display. And let me just make that a bit easier to read. And essentially all it is when we are in our start method, we're going to first check the card info and see what enum it is. So we're going to see if it's actually a unit card or a spell card. And then if it's a spell card, then we're going to be essentially just setting half of the information that we need. And otherwise we will be setting all the information because the unit requires all the information. So that's essentially how this displaying of cards and the setup of cards work. And the next thing we're going to talk about is another important part is the setup. So we're going to be making a deck. We're going to be putting the cards into the hand and the deck. And we'll also be creating a graveyard where we can put our discarded cards, or if our hand was too full, we'd be putting our cards there. So now we're here back to this fairly familiar scene where we draw cards and add them to our hand. So I'm going to be covering how I did this system. And before we get started on that, I'm going to show you a small diagram of what to expect in this system. So we have 3 different containers. Essentially, we have a deck, we have the hand object that holds the cards in our hands, and then we have a graveyard object, which the cards are sent to when, let's say, we have too many cards in our hands, or if cards are milled, discarded, so on, right? So we have that system in place. All of these are essentially just containers that hold objects, and they're all connected to the card system script, which is essentially the controller for all of this. All the information and all the cards that are being passed back and forth are going to be handled by this card system script. And let's actually take a look at how the deck is constructed in the first place. So you actually might notice that there is a test deck object here. And that's correct. It is a deck object, and the deck object is essentially just a list of card objects, right? Because we don't essentially need to store the instantiated versions of our cards in our deck, because the deck is only a container for information, right? So what happens is that we can just load our objects in here, and you can see that the first card is it's a unit card, right? So if we were to go back to our card system script, you could see here on the inspector that we have a deck list, which is essentially the object that we're reading from. We also have 2 things here. You can see card templates. We have the unit card as well as a spell card. And essentially these are the prefabs that you saw in the previous scene. So if we were to open it up, you could see that it's actually the exact same prefabs. Let me just find it here. So yeah, it's just these two. These are our templates that we're using because we just have to instantiate these depending on what card we get, right? So obviously our script will need a reference to these so it knows to instantiate these. So let's actually jump into the code, and we'll take a look at how this actually works. Here we are back in Visual Studio, and you can see here we have our deck list script, and this should probably be renamed to deck list object, so I will do that afterwards. And we have the same thing as the card objects. It's essentially just a scriptable object, and it has a list of card objects which make the deck. So where are we going to be using this? If we take a look at our deck script next, you can see that all it has is a serialized field that will allow us to see the actual deck in the inspector, and that is all this script is for. It's to contain a list of card objects. And you can see here there's no mono behavior or anything, it's just a class. And we have the class constructor here, and essentially what it does is it takes the deck list script, or the deck list object that we had before, and what it will do is it's going to make a new deck list for the card objects, and then for each object in the deck object that we made, it's going to copy it to this new list that we've created. And essentially why we're making a copy of this is because if we directly modify the object itself, let's say we started the game and there's 5 cards in the deck, and we drew all 5 of them directly from the object, the next time we load up the game and we hit play again, there's going to be no cards in the actual deck itself because we've actually removed them by directly modifying the object. So that's why we actually have to make another copy of it, essentially. And if we look at the functions that we use, we have draw a card. Essentially, if the deck is not empty, then we're going to return the card that we drew. Otherwise, we're just going to print there's no more cards in the deck and return null. And then pretty simple stuff. Get deck size just returns the current size of the deck. And let's look at the graveyard script afterwards. It's the same thing, essentially, without the constructor. It just makes a new list of card objects, and we're going to be storing our cards in here. If we, let's say, discarded a card, used up a card, or let's say we milled a card as well. The hand script is a bit different, but it's roughly the same thing. Just same thing with the list of game objects instead of card objects this time, because we're going to be storing the cards that are instantiated in this list, and we're going to have a max hand size of 8. And that's about it. So you can see that all 3 of these scripts are actually extremely generic. They're actually essentially just containers with very few methods or functions that perform a few basic actions. So let's go back to our card system script, and you can see that the meat of, the logic is built here. And let's actually go jump back into the Unity editor and look at the inspector. So you can see here that we have the deck list, which is the decked object that has our cards that we want to play. And this DCS thing, don't worry about this. It's just the debug canvas to show the information on the screen right now. And we have the player hand UI, which is this hand panel, which is at the bottom. You can see here. This rectangle right here is the panel itself. And we have 2 things, which is really important, which is the card templates. We have the unit card and the spell card. And these are, if you recall from our previous scene, these are the things that essentially are our templates, the unit card and the spell card. And we're going to be picking which one we need to instantiate based on the card that we drew. So let's actually jump back into MVS Code. So now we're back in Visual Studio, and we could take a look at the actual logic. So when we start, all we do is we make a new deck script for our deck object. Then the same for hand and grave. And you can see here that we actually instantiate, or not instantiate, rather we construct the new deck with the deck list that we will be using. And then we have 2 updates for our canvas, which we don't have to worry about. And the only function that we have here is draw from deck. And this is fairly important. So we instantiate an empty object, which is the card that we are going to draw. And then we're going to draw from the deck, and we're going to get a card object. And as long as the card that we drew is not null, then we're going to perform the rest of this information. We're going to update the deck count for the UI, which we can sort of ignore here. And then if the current hand size is not hand size max, then we could just add cards because we actually can hold more cards. And this is really important. The card drawn type is what we'll be using to distinguish between spell cards and unit cards. You can see that I wrote a function here, draw card type, which is right here. All it does is it takes the card itself and it's going to check the enum, and just if it's a unit, then return 0. If it's a spell, return 1. And then we're going to be using that to check if the card drawn is 0. So if we drew a unit card, then we're going to instantiate with the unit card, template that we had before, and we're going to let the parent be the player hand UI, and I'll go back to why that's important later. So after that, we're going to be changing the component, which is the card display. We're going to set the info to the card that we just drew, and that lets us change the information on the card, and then it's instantiated into our hand. Afterwards, we have to make sure to actually add the card to our hand, because adding it to this transform, player hand UI, is not enough. We actually have to logically add it to the list that we have. And same thing for here, but this is for the spell card instead. And then if our hand is full, we're going to be adding the card to the graveyard instead. And otherwise, there are literally no more cards. And then we'd implement something here if we had fatigue damage or something. So that's all that is. And let's actually see it in action. Before we actually see it in action though, I'm going to talk about the hand panel. So essentially why we need to set the parent, as you can see here. I forgot to switch it around, but no biggie. So as you can see here, we actually have the second parameter as the player hand UI when we instantiate the card. And that makes sure that the parent object is this transform. So let's close Visual Studio for now and look back into Unity. And you can see here that we have a horizontal layout group right here attached to our hand panel. And that's why it's so important, because whenever we add a child object to this horizontal layout group, what's going to happen is, let's say if I put image here, it's going to sort of lay it out properly depending on our rules. So if I just duplicate this, you can see that they're sort of spacing themselves out evenly. So we sort of need that to ensure that the cards themselves will be added properly. So let's actually just take a look at this before we get in. We look at the card system. We have that list that we created before. The hand panel is the parent that we're setting our instantiated objects as, and we have two things, which are the templates that are to be instantiated. So we have 20 cards in deck, and we have cards in the graveyard, which is 0, which makes sense. Let's take a look at our deck right before we start. So the first object that we're going to draw is a unit card, right? And we have to make sure that the correct information is actually displayed. So we draw a card, it is indeed a unit card. And we can see that if we go back to the code, we can see that it is instantiated right here. So the card that we drew, instantiate is unit card, because that's what we detected here. And we're going to set it to the parent. And then once we've done that, we're just going to change the information to the card drawn, and then it changes the information, and then we just add it to our hand. So that's actually how that works. And I am fairly surprised at how well it works. It doesn't really seem to break, as I may have thought it would be. So one problem would be, let's say, one potential problem that I see here that it hasn't happened to me, so I don't think it actually is a problem, is that when we instantiate it, maybe it, it calls the start method for the card display before we can actually set the information. So it sets it as null, or just information that isn't there, and that's no good. So that might be the only problem, but I've never seen it happen yet, so I don't think it will be a problem in Unity. So that's one thing to be aware of. Yeah, and that's essentially it. And then just draw a few cards, and the layout group separates them properly. And if we draw cards that are over our hand size limit, then we're just going to add them to our graveyard. Yep, and that's about it, honestly. So very simple, just containers holding card objects, and then the card objects have the information to actually display the information when proper prefabs are initiated, or instantiated rather, with the information that we've given them. And this is essentially just the beginning that we need to take in order to, make a proper card game, in the sense where this is just the foundation that we need. And there's a lot more to do in the future those being like adding proper effects, animations, and so on. So I hope that you enjoyed this video, and thanks for 11 subs. Wow, right? Like I didn't even think I get like 5, right? So wow. So honestly, if you guys don't like this, then honestly just leave a comment of what you want to see, because I really don't have much to do right now. So thanks for watching, and I'll see you guys next time.